Hey everyone, welcome back to Ostia Biomedical Engineering. My name is Balaji, and today we'll be diving into prosthetics by design, how engineers have rebuilt the human body piece by piece. And along the way, we'll cover the skeletal system too. Let's start at the beginning. This is section 1, the history of prosthetics. Before we get into circuits and microprocessors, it's worth understanding that humans have been solving this problem for thousands of years, long before anyone had the technology we have today. The earliest known prosthetic dates back to 950 BC in Egypt, a wooden and leather toe attached to a mummy. What's interesting is that this toe showed real signs of wear, which means it wasn't just placed there for burial. Someone actually walked on it while they were alive. Fast forward to 300 BC in Rome, and you get the story of a general named Marcus Sergius. He lost his right hand in battle and had an iron hand built so he could still hold his shield and go back to fighting. That's over 2,300 years ago, and people were already engineering solutions to get back into their lives. Then in the 1500s, a French military surgeon named Ambroise Paré took things further. He designed metal hands with fingers that could actually move using catches and springs. For that time period, that's an incredible feat of mechanical engineering, centuries before anyone had electricity, let alone motors. If you look at the big leaps in prosthetic technology, they almost always line up with major wars. That's not a coincidence. The American Civil War between 1861 and 1865 caused over 30,000 amputations. That created a massive, urgent need for prosthetics that actually worked, not just looked the part. Right after 1862 into the early 1900s, the US government started funding prosthetic research and production for veterans for the first time ever. That's the moment prosthetics shifted from individual craftsmen to actual organized industry. By the early 1900s, lightweight aluminum started replacing heavy wood and iron, making devices easier to wear for long periods. Then World War I and World War II pushed things even further. Better suspension systems, improved socket fits, and body-powered hooks that gave users more control. And by the 1970s, we hit a major turning point: myoelectric prosthetics. These use electrical signals from the body's own muscles to control a prosthetic hand. That's the first time a prosthetic responded to what the body was actually telling it to do, rather than relying on pure mechanical movement. The Bionic Age. This brings us back to what we've called the Bionic Age, and the difference between an 1800s prosthetic and a modern one is honestly massive. Back in the 1800s, users manually cranked and snapped fingers shut around objects. There was no automation, no sensors, just basic mechanics. You could swap the hand out for different attachments like hooks, brushes, or even eating forks, depending on what task you needed to be done. A lot of wearers added lifelike details like fingernails and wrinkles carved into the wood. And prosthetics were built to match the length of the natural arm to keep the body looking symmetrical. Now compare that to modern prosthetic arms. These use microprocessors, sensors, motors, and even machine learning to function. They can read electrical signals from a person's residual muscles and translate them into precise movement. Some can even provide sensory feedback, so the user can actually feel texture and pressure through the prosthetic, and some of the most advanced versions today can be controlled directly by the mind using brain-computer interfaces. So in less than 2 centuries, we went from hand-cranked fingers to devices that can read your thoughts. That's the kind of progress biomedical engineering makes possible.